Geometry, note section 1.4, addition postulates. There are two of these postulates. There's the segment addition postulate and the angle addition postulate. Conceptually, they are identical. In practice, the angle ones are a little more complicated because more letters are involved. Let's first discuss what the word between means. Giving you a definition of this is complicated. Let me give you a description. Let's say that B is between A and C. If I were to draw a segment AC, it just means that if A and C are the endpoints of the segment, B is someplace on that same segment. Here's what it does not mean. Between does not mean a midpoint. This does not guarantee that this point is halfway between A and C. It does not mean that. It means it's between. Segment, we've had this definition before. Let's have her again. A segment consists of two endpoints and all the points between them. So here is segment fx. Shorthand for this, segment fx. Guess what that's congruent to? That's congruent to segment fx. Yes, it's congruent to itself, same size and same shape. We could say the length of segment fx, or the measure of fx, is equal to the length of segment fx. Lengths are equal, segments are congruent. Angle addition postulate. Remember, a postulate is something that we assume is true because it seems pretty obvious. This has an if or only if in it, so we can do this forwards or backwards. So let's do it forwards. If A is between C and T, then CA plus AT equals CT. At first glance, it's like, whoa, that is complicated. Let's draw a picture and see that it's not complicated. So first of all, if A is between C and T, here's how I could draw that. Here's C, here's A, and here's T. What conclusion can we draw from this according to the segment addition postulate? The measure of CA plus the measure of AT should equal the measure of AT. CT, I might have said AT at the end there. So with numbers always makes it easy. If this is 3 and this is 7, then this whole length has to be 10. That makes sense, right? 3 plus 7 equals 10. It's essentially what this is saying. We can do this backwards. I'm going to get rid of these numbers because it's not part of the postulate. It's just to help you understand. You can leave them there if you want. I could say this backwards, and I could say if CA plus AT equals CT, then the conclusion that I have to make is that CT is the segment and that A is someplace on that segment. Let's look at an example and see if we can put this into practice. Find the length of OG. I'm just going to write that off to the side. That's what I'm supposed to find. If O is between D and G, well, I should draw a picture. D is an endpoint, G is an endpoint, O is someplace between them. Doesn't mean midpoint, it means between. DO is 2x minus 4. When you write something on a segment, you are to assume it goes to the two closest points that are named. So it goes from D to O. If you want to put these little things on there, that's cool too. OG is 3x. So we're assuming it goes from O to G. DG is 26. Now, if I were to just throw a 26 on here, we wouldn't know what it represents. Since there is a point between D and G, I'm going to make one of these braces. and say that this is 26. Once the information is put on the picture, which it is, we then want to make an equation from a definition, theorem, or postulate. And we have this postulate we just learned, the segment addition postulate, which says, if O is between D and G, which it is, then DO plus OG equals DG. So that's the equation we're going to write down. We're always going to write the equation down first with letters if letters are in the problem, and they are. D to O plus O to G equals DG. Then we substitute with what we know. Generally, when we substitute, we use parentheses if there's more than one thing on the same side of the equation. DO is 2x minus 4. OG is 3x. And DG is 26. Now, I just said generally when we substitute, we use parentheses. On the right side, there's only one thing, so it's all one group. Do these parentheses change the value of what's happening in this problem? They do not. Do they sometimes change the value? They do if we have subtraction in the problem or multiplication. We don't really have that in the groups that we have here. So if we combine like terms, 2x plus 3x, well, that's 5x. And then a minus 4, there's nothing to add that with on the left side, so we got 5x minus 4 is 26. Add 4 to both sides of the equation, you get 5x equals 30. Then divide both sides by 5, and you get x is 6. The question doesn't ask for x. The question says, find the length of OG. Well, OG, according to my picture, is 3 times x. Since we know x is 6, we're going to get 18. Now, when you're finished, if your work is not written in a logical manner, let's say I'd written this over here, and I drew this picture over on the right. It's not a very logical manner. So a method that you can use is you can label things in the order in which you did them. That way, when the reader looks at this, and you're the reader, you're going to look at this later when you're studying for your tests, you drew the picture first. You made this equation and solved it. Then you figured out what OG was. If the problem was multiple steps, and I would argue this was minimally 3 steps, label each step. It's going to make everyone's life easier. Number 2, the picture is already drawn for us. MA, it says, is 5x minus 3. Put that on the picture. AN is 30. Put that on the picture. MN is 8x minus 6. I don't have a lot of room above this, so I'm going to put this down here. 8x plus 6. We're just supposed to find the value of x, so this should be pretty straightforward. We want to first make an equation from a definition, theorem, or postulate. Segment addition postulate. MA plus AN equals MN. MA is 5x minus 3 according to our picture. AN is 30 according to our picture. MN is 8x plus 6 according to our picture. On the left, combine like terms. 5x doesn't have a like term. A minus 3 and a plus 30 is a plus 27. The right side doesn't have any like terms. Now we're going to add and subtract to get like terms on the same side. I'm going to subtract 5x from both sides and get 27 equals 3x. I'm going to subtract 6 from both sides and get 21 is 3x. And divide both sides by 3 and get x is 7. The question simply asks for the value of x. It's 7, so we are finished. There's 2 examples of the segment addition postulate. Next, we have the angle addition postulate. Same concept. It appears to be more complicated because there's more letters involved. If R is in the interior of angle PQS, well, this says if and only if. So I'm going to read it first. If this is true, then this is true. And then we can look at it backwards. So I have angle PQS. Says R is in the interior. So this is the interior, this is the exterior. So someplace in here, there's an R. Don't know where, someplace on the interior. then the measure of angle PQR, PQ, there's no angle PQR in this. So I need to draw this angle by putting a ray that goes from Q through R. Measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS. So with numbers, I'm going to end up erasing this. If this is 30 degrees and this is 70 degrees, it seems reasonable that this angle here is 100 degrees. That's all the angle addition postulate's saying. Looks complicated because there's lots of letters. Then the conclusion we can draw from this is that the measure of angle PQR plus the measure of angle RQS, equals the measure of angle PQS. This one plus this one equals this one. Cool, 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 cool. And we could do this backwards because it's if and only if. If this is true, then we know R is on the interior of the angle. Check out example number 3. Given the measure of angle MAT, that's this angle here, is 60. Now to put this in my picture, I'm just going to draw a little arc with an arrow on it and call it 60 degrees. This doesn't mean congruent. The arrow just means I'm pointing it out. Measure of angle MAH is 140 degrees. Put that out here. Measure of angle TAH is 4x plus 20. Let me show you a terrible way to do what I just did. And it's not technically wrong, but you're going to get yourself in trouble. Had someone did this and they said, okay, this angle here is 140, this is 60, and this is 4x plus 20. Technically, it's not wrong. But your brain doesn't like this because this is the biggest angle, but the arc is the smallest. And that creates some problems with it making sense in our brain. If the angle you're using is bigger, draw the arc further away so that you can see that it's bigger. It's a suggestion that I strongly recommend. I won't count it wrong if you ever draw it like that. So what equation can I write? According to the angle addition postulate, since T is in the interior of this angle, measure of angle MAT plus the measure of angle Ta equals the measure of angle Ma. Measure of angle MAT plus the measure of angle Ta equals the measure of angle Ma. Do you have to write this equation to get full credit for the problem? Yes, you do. You don't want to write it? It's fine. Just know the consequences is that you will not get full credit. It's a decision you have to make for yourself. Is it worth it? So this is 60 degrees. Measure of angle Ta is 4x plus 20. I don't need to put the degree symbol here, by the way. This is 4x plus 20, and the big angle, Ma, is 140. Don't need the degree symbol when making this equation. Pre-calc will need it. Calculus will need it. Actually, in calculus, we never use degrees. Geometry, if you don't put it, it's fine. It's kind of a good habit to do it, though. Combining like terms, 60 and 20 is 80, so I got 4x plus 80 equals 140. If I subtract 80 from both sides, I get 4x is 60. If I divide both sides by 4, I get x is 15. What's the question asked? Find the value of x. We found the value of x. It's fine. That's Italian for finished. Number 4, very similar picture. Measure of angle LOE is 84. Now that's the big angle, so I'm going to put that here on the outside. Strongly encourage that. Measure of angle LOV 4x plus 1. Measure of angle VOE is 5x plus 2. According to the angle addition postulate, the measure of angle LOV plus the measure of angle VOE equals the measure of angle LOE. Now, if I substitute measure of angle LOV according to my picture, that's 4x plus 1. When you substitute, it is wise to use parentheses. Measure of angle VOE is 5x plus 2. When you substitute, it's wise to use parentheses. Measure of angle LOE is 84. Since the right side is all one thing, using parentheses over there is kind of strange. Combine like terms, 4x plus 5x is 9x, a 1 and a 2 is a 3. So we get 9x plus 3 is 84. If I subtract 3 from both sides, I get 9x is 81. Divided by 9, I get x is 9. Find the value of x, we did it. There's more, find the measure of angle LOV. Measure of angle LOV is equal to 4x plus 1. We know x is 9, so it's 4 times 9. That's 36 plus 1. That's 37. All right, that concludes the notes. Do the assignment that is on the website.